Okay, so good morning, good afternoon, good evening, everyone. So today we will discuss about we are we are heading to the actual Wireshark, I would say. Uh, so far we have discussed about layer two, layer three, and parameters of layer two and layer three, and IP options. We have covered the most, and that's very essential. And I would say that that is most widely used options we discussed in the layer two and layer three. Now we are heading to TCP/IP. I can't open this file. Okay, so now so far we did with all this. Yeah, we discussed about IPs, as I said, we discussed about fragmentation. We saw the ICMP options, the most essential options, and most widely used when we are troubleshooting it. Yeah. And now we are heading to TCP and UDP protocol. And today we are focusing on TCP. So TCP is a fundamental. I mean, most of the applications they use TCP. And if you look from the OSI perspective, we know that TCP is a layer four. So when we say transport, when you send a traffic, example from source to destination, you just imagine that IPs or your actual the path it takes to reach the destination. So it's like A to B. A got an IP address, B got an IP address. So it's just an IP to IP communication. That's it about the layer three. So how this package is send it across and how it leaves a particular IP and how it reaches the destination. That's something we call it as a transport. There are two different terminologies, and or maybe they we have to differentiate the transport. Some people they say in your WAN connections they say you got what kind of transport you have. Is it an MPLS or it is a direct internet access? That's a different transport. That's a physical transport. That's your underlay connection. But your TCP is your actual transport for your protocols. Example, your HTTP request that goes out from a client, so it make uses of a TCP. So it depends on the application. So every application uses a either it can be a TCP or UDP, most widely used. And when you compare TCP and UDP, the TCP is most widely used compared to UDP. Even UDP has its own dependency like your DNS, your DHCP that runs on top of UDP. So that's something the understanding you should have for TCP and UDP. That's a very basic foundation of transport protocol. So we are going into the TCP fundamentals. So when we do the what is that the communication or when you do a packet capture for any kind of traffic, right? You're troubleshooting. It can be your troubleshooting or you're just learning about Wireshark. The maybe some people may have confusion. I'm talking about the beginners who just getting started with Wireshark. Um, but maybe some people they have an hands-on experience with this. They know this very well. So TCP is a peer-to-peer communication. That's the very fundamental ideology. So to do that, let me open this presentation. You will understand better. Say, for example, you got a client here. You got a server. got a switch, maybe this is a client, and maybe you got your firewall. Can be any firewall. What happens here? Just a packet flow. Even this is a topology we have. So what I am telling here is that the source network, 50 network, and I am writing a rule here. I am doing a default routing on the switch to the Palo Alto, right? So it can be an IP address. You got two legs. I mean, one is in and out. Yeah. So I am telling all this default routes. So if it is not directly connected, if it tries to connect to anything outside in the internet, so it has to go to the firewall. So example, the firewall IP can be 50,002. So default route go to 50,002. Okay. So now my source here, I got a computer and I got 50,003. And this is 50,002 here. And this is 50,001 here. Let me take a different color to differentiate better. I got 50,001 here. So what happens here? A connection from a client, right? So this is a client. So it tries to make a TCP connection to 8.8.8.8. So even though the packets are routed, I mean, from here it is routed back to the firewall, firewall routes us back to the switch, and it goes out to the internet. This is how the routing happens. So now we are going to the layer 4. So when we say three-way handshake, it's a communication between this 50,001 and 8.8.8.8. So how the connection, why I am telling that this is a peer-to-peer connection, 50,003 goes to 8.8.8.8. It doesn't care what is in the middle. You know that this IP routing is not directly happening between 8 and 50. There can be multiple IP networks in the middle that routes your packet to 8.8.8, but we don't care about that. All we are focusing here is what is the TCP connection between my source and my destination. So when I say peer-to-peer connection, I don't care about any routing in the middle. As I said, I don't care about any routing. So it is purely a peer-to-peer connection. So this is client and this is server. Take this. This is 10,003. So there is routing in the middle. There are multiple devices connected. Let me erase this. So you can imagine there are a lot of small, I mean, not small. I mean, there are all IP routing happening in the middle. But finally here, it connects to a switch. Here it connects to a switch like this. I don't care. It can be a firewall or anything in the middle. So this is 10,003. So this is a basic. So that's why we're doing a little bit of whiteboard here. We'll jump into the practical. Just want to give a glimpse on how it works. So it can be 8, 8, 8, 8. So I don't care about the devices in the middle. So all I check is my connection between 10,003 and 8.8.8.8. And we say this connection is a 4 tuple connection. Why? What is the focus? I mean, what should I see in my TCP connection? So I should see my source IP, my destination IP, source port, and the destination port. So here comes the challenge, right? So what if somebody in the middle, right? Even if this guy, if he is blocking a specific port, example, you are trying to establish a connection on you're trying to establish a connection between these two and you're using HTTPS. So you're trying to establish a connection on 443. So this is my destination port 443 and my destination IP is 8.8.8. Source IP is 10.0.0.3 and source port is a dynamic port 43678. An example I'm telling. So what if there is a device in the middle, if it is blocking the port 443, your TCP connection will never happen. You can't establish a successful TCP connection. That's something you should understand. So where could be the, what is that? Who is resetting the connection, or I would say specifically where this particular port is filtered or blocked. So when we say filtered, I mean, we saw that in the ICMP code, if there is an ACL, it says that it is it's administratively, what is that, filtered. If you see an ICMP code as ICMP, sorry, administratively filtered, it means that there is an ACL or it can be a rule that something blocking it. I have shown you in the last class. So if there is the port is being administratively blocked, you can see that using this, when we did that ICMP, you can see that, or else reset. So you got two possibilities for reset and administratively filtered if the port is being blocked. So now coming to the actual TCP connection. Let's go a little fast with this now. So we all know this. It's a three-way handshake. So what happens, as I said, I'm not going to define the IPs here. So I got source port, I got destination port, I got source IP, I got the destination IP, right? So the same thing here, source port, destination port, source IP, and destination IP. Now, so when I do this, right? So this is a first packet, it's called SYN packet. So I should receive the SYN-ACK back from the server. So instead, if I see a reset in the beginning of my three-way handshake, it could be because of the port being blocked, port being filtered or blocked. But how do I mean, how do you find, I mean, who is doing it? Is it source or destination? With the help of Wireshark, that's helpful. That's something we can figure out. Example, if this particular port 443 is not open, there is no service open on port 443. So obviously what it happens when it tries to do a SYN, what it does, as I said, it does with the 4-tuple connection here. So the destination port is something we are focusing on. We are trying to establish a connection over the port 443. But this guy, I mean, this server is not running 443 service, and it's going to send a reset instead of SYN-ACK. You should see the reset packet coming in from the server. So that way you can figure out, okay, the service is not running on the destination. There is nothing problem on my end. That's how you can differentiate. This is a flow you should understand. This is a very basic for all your troubleshooting. So coming to the other use case, I will do it in practical, you'll understand this better. The same scenario you can take client, server, let me use a different diagram. This is a client and this is a server. So I see a successful three-way handshake. Three-way handshake is successful. But down the line, if you see the traffic in the Wireshark, at one point you should see a packet, fin packet. Fin is a graceful tear down. So what do you mean by that? I mean, it says that, okay, we are done with the conversation. I'm trying to download a file. So I have downloaded the file successfully. So now we can go ahead and we can not terminate the connection. We can finish this. We can finish the conversation. I am done with that. I got all the data, whatever I wanted. So now we can go ahead and we can gracefully tear down this connection. And after this, right, after this fin packet, or maybe if your three-way handshake is happening successfully and you see the reset in the middle, don't get confused. Sometimes what happens, the client sends the reset packets because it is done. I mean, some packets it marked with a push packet. If it comes with a push flag, I'll tell you there's a flag. So we will see that we are just in the beginning of we're in the tip of the iceberg of TCP. So push packet is something if a client sends, it's going to do a reset. So without the fin packet, it closes the connection. So how do you apply this logic? How do I apply? If there is no three-way handshake and if I see a reset, the port is blocked. I see a successful three-way handshake and I see the sequence number is advancing. So it proves that my connection is properly happening and it's going well. And maybe at the end, I see few reset packets. That's fine. I mean, we don't want to bother about that. That reset is because of the push flag. Push flag is telling that the client is telling that you give a priority to me, you send the packet as quickly as possible. That's something client is telling them. So for that, it sends a push packet. For that, it resets a connection because I'm in a hurry. I want to do other stuff. So I'm going to send with I'm going to mark my flag with push packet. So I'm going to send out this to you and you send me back the data. And we are closing the connection. So reset, as I said, you have two scenarios. If the reset happens before the three-way handshake, it's a port is blocked somewhere in the middle. And who is doing the reset? That's something we can figure out. And if this you don't see the reset in the beginning, but if you see the sequence number is keep advancing and you see all your packets, and maybe in the end or in the middle you see few reset packets, don't just mislead it or don't just uh, confuse. I mean, it is okay to see few reset packets. That happens. And you have to check for your push packets. Is it your real communication is happening? There are a lot more to check. So this is very fundamental of TCP IP three-way handshake. If you understand this, yeah, then it won't be a hard. I mean, with the other topics, you don't feel hard with other parameters of TCP IP. So now let's go back to the topology. So let me open the terminal, see what we can see here. So now let's open the Wireshark. Yeah, we know this connection. So I'm trying to reach the internet. Yeah, from this machine. Yeah, we have the Wireshark on this Windows machine. So I'm going to do that now. Let's see what we see in the three-way handshake. So let me do HTTPS 888. Before that, let me open the capture. So if you see this traffic is going on the Ethernet interface here, make it little bigger. So I'm going to filter only for 8.8.8. Okay, so now focusing only on the Wireshark. So what should I see here? Okay, so edit. I just installed this Wireshark. I have to do some changes quickly here. View. I'm going to my time display format. I'm going to do it second since previously displayed packet. Okay. So from this, we can calculate the round trip time, as I said, right? Let me take my pen. So here you can see your round trip time, right? RTT. So the packet has been sent with 0 seconds. It reached the 8.8.8, and you can see the port numbers here, right? 50126 is a source, and this is the destination. I said this is 4-tuple connection. So this is the destination, and this is sending back to me. This is the source, my computer, and it comes from 4.443, and it reaches 50126. This is a well-known port. We are establishing a connection over the HTTPS. So we got this 4-tuple connection. The other parameters or maybe the other details you should focus on. It is whatever you see after this dot on your right hand side, it's all seconds. So when you see something on the left hand side right here, it matters because that is going beyond the milliseconds. So now you see this is 247 milliseconds right here. So what is the round trip time? So it takes just 247 milliseconds for me to send and receive my packet back from 8.8.8. And you can see this is a SYN. This is SYN back from the server or the destination. And again, the source, it's asking for the SYN. So it means that, okay, I got your SYN. It is telling that I send a SYN. Again, the server is sending a SYN back. And for this SYN back, this guy is acting it. He's telling, okay, I got your SYN. That's the meaning of this. There's a 4-tuple connection, as I said. So what are the other parameters we should focus on? So here comes your MSS, your MTU. Will go a lot deeper about that. We open this. So if you open this flags, the very first packet you should see here, it is a SYN packet. How do I check that? You have to go to the transmission control protocol. Right below that, if you expand this field flags, you can see the SYN. That's from the client. So this is a SYN ACK. If you see this, I see one on this acknowledgement set and one on the SYN set. And this packet from the source to destination back again, it's just acking the packet what it received. I mean, it is acking for the SYN ACK. It got, it was received by the client and it is acking for it. So if you look at this now, exactly your TLS connection happens here. So from here, everything is encrypted. We have a separate TLS topic. We will discuss in detail about that. But for now, the how this three-way handshake happens. So now if I look at this capture, I know that there is a successful connection between this source and destination. So let's see if you do a testing with a different IP address, if it's a non-routable IP address, how it looks. And as I said, what are the other key things? If you see the SYN-SYNAC ACK, so it means that your routing is good. We discussed this. And as I said, always look for your 1 minute. Let me open this. Okay. Always look for your destination IP address for your TTL. In most cases I have seen, you will get the perfect output. So it is starts from 128. There is 4 hops away. So my routing is happening. So that's why I got the Synac pack from this guy. If you go to any capture, even after TCP, right? So I'm going after the TCP, even I see this packets, even in my TLS, your TTL remains the same. So if there is no TTL is not decrementing, there is no point in checking all these details. And right away, you will see your TCP reset here. That's how you should compare your theory with the practical. So if you compare your OSI model side by side with this Wireshark, you'll understand what I'm telling. So this is an IP field. TTL is something we see this in the layer 3. And I am telling that there is a proper routing happening. There is no ports being blocked anywhere. This is good. And I see client hello, and I can see server hello. And if you come back, drill down, down, if you see right over here, okay. So here, my TCP connection is successfully done between source and destination. You see, this is a FIN packet. And I don't see any reset packets here. And on top of that, what is the very first thing you guys have to do when you see this capture? You have to click on this expert info. Do you see any reset here? So if you see this, I don't see any reset packets. There is only one duplicate acknowledgement packet. I'll come back to that about the duplicate acknowledgement. Why do we see that? If you see this, there's a FIN packet. See how many FIN packets I can see here. A little bit of retransmission happened, and I see all this as a FIN packets. So this will give you a bird's eye view of all your protocols. And you should focus on the expert info and what exactly you are looking for. It's based on your troubleshooting and based on your scenario. So here I don't see any reason. So this proves that this TCP connection is clean. I don't have any problem with my TCP three-way handshake with this. So now let's go back to the slide. So TCP fundamentals observe the TCP three-way handshake and connection terminations. And now we are going to do this. How if it is the connection is terminated, how do we see that? Identify handshake failures and server service refusals. That's something we are going to test now. Let's again jump back here. So this is a clean capture. So now let me try a different scenario. Now I'm doing a HTTP to 8888. Same IP address, but I'm just changing the protocol. And parallelly, let me run the Wireshark. I can see the traffic going. So I'm giving HTTP. So what happens? Let me stop this capture. So I'm focusing only on IP address 8.8.8. That's the destination I'm trying to reach. There's no much traffic here. So this is something you should understand. there is a default TCP timer. This is the source. This is the destination, right? So we discussed about this. And if you look for this capture specifically, I'm now this is important. So I got all this capture. So I want to follow one stream of data. The first packet which we tried from the browser. So I'm going to right click conversation filter, and if I do a TCP, see this shows me the first packet which I sent. Yeah. And if you look at this, so as I said, with this you can conclude you have a routing. Yes, I do have a routing. Is it the port is blocked? That's something we're going to investigate, right? So if you see this, do I get any kind of reset? I didn't get any reset. But what happens here? See the very first packet it sent, and there is a TCP timer. I think it is 30 seconds. There is a default TCP timer. So when it sends a SYN packet, if it is not receiving the SYNAC back from 8.8.8, this again it's going to retransmit the data. That's the meaning of retransmission. If you look at this, it is retransmitting the data again. So again 30 seconds, I didn't receive any response back. Again, it is retransmitting the data. Do I see any resets here? No. But I know that when I connected this, when I tried the connection with HTTPS, it worked and I saw this TTL decrementing, but here nothing happens. Because this particular port, right? They're not allowing this. I mean, the particular service is not running on it. So if somebody is trying to connect to 8.8 over port 80, it doesn't work. So this doesn't mean that this particular destination is down. So it changes based on your scenarios. That's what I'm telling. So this is how you should understand this better. Don't ever confuse with retransmission. There are a couple of other scenarios I will show you where you can see the retransmission, but the whole point is I send a SYN, but I didn't receive a SYNAC back. What does it mean? So 8 is not interested to talk to me over the port 80, but it doesn't reset. It's pretty instead. The client is keep trying sending the retransmission, but I didn't get a reply back for my SYN. Now again, let's go to the export info. Nothing. It keeps retransmitting the data. And one more thing I want to show you. I'm doing the same for HTTPS. Yeah. Let me open the capture again. Okay, so let me open the Wireshark again. So let me go to 8.8.8. Something. Let me start this from the beginning here. Yes. 8.8.8. don't see any TLS traffic. Okay, let's take this example. So it is trying to reach a different destination here. So what I want to show you is, uh, one minute, let me show you this. So we discussed the three-way handshake, and the other thing with the filters, we are coming to the filters and the options. Yeah. So here, the three-way handshake, I think I want to show you something with a slide that helps you to understand better. Once again, let me pull up that exact slide. Okay, yeah, exactly here. So now imagine that the three-way handshake is successful here. We have the sender and receiver, and we are doing a TCP here. So the TCP connection is successful. As I said, this is a closing the connection. You see the spin packet. So now we are going to learn about what is sequence number and acknowledgement number. And really it matters. Yeah, definitely yes. We should know about that to dig deeper and to troubleshoot. So here, when you see the three-way handshake, right? With the filter, I will show you. If you go to the same, it's all we are dealing with now, layer 4. Yeah. If you go down, there is an option for the sequence number. So this is something I want to tell you. See, there is two sequence number. The relative sequence number is something the Wireshark is doing it for us. That's helpful. That is very, that makes it life easy with its own sequence number representation. If you choose the raw sequence number, what is the raw sequence number? One second. Oh, I think I want to change some setting, relative sequence number, relative acknowledgement number. There should be an option for the raw sequence number. Let me open my Wireshark. I'm just taking a packet here. Yeah, I don't know why it is not showing up there. So here is an option, right? It's a, oops. So this is a raw sequence number. That's something we should not use the raw sequence number for filtering. So always use the relative sequence number and relative acknowledgement number. This is actually done by the Wireshark for us, and that's something we are going to use it for the whole learning and troubleshooting. Whenever you see a relative sequence number, that's something you should focus on. So right click this sequence number, relative sequence number. That's something the Wireshark created that form for us. So you can apply as a column. So if you look at this as a sequence number and the acknowledgement number. And since we don't need the full name of it, you can make your own naming convention. If I go here, edit column on it, instead of this, I will make this as a SQN hash. So I know this is a sequence number because you can see the output better. Right click on this, edit, acknowledgement is ACK hash. So if you see in the first three-way handshake, do I see any kind of data? This is something we say this is a ghost byte. I mean, it doesn't exist. This is just an imaginary byte. If you look at the still client hello, I didn't see any packets being sent, either from the source or destination. So this is a sequence number, is your actual data. That's something I want to tell you. So if you look at the sequence number, see, it starts with 0 and it goes and it goes and it ends in 9274. So until we finish this conversation, 99,274 bytes of data is being exchanged between client and server, right? So right from SYN to the all the way back to your bottom, and you can see 9,274 bytes of data. Even you see this says the sequence number is 9274. And don't get confused with your length. We are just focusing on sequence number and acknowledgement. This is very important for you because when you deal with TCP window problem, when you face problem with your latency, this fundamental helps you to figure out where the problem is. See, this is a good connection because I don't see any kind of latency over here in the left-hand side. Yeah. So here, if you see, it starts from 0 and it keeps incrementing, and I see 9,274 bytes of data. So now let's jump back to the PPT. So here, a client initiates with sequence number 100. So it's sending the 100 bytes of data. This is something we are talking about the payload. See, it got the sequence number 100 and it acknowledges 101. So it is telling that it adds one more byte on top of your sequence number, and it is telling that I got this 100 bytes of data. If you see this arrow mark, it's going back to the client and it is telling that I am acknowledging your sequence number 100 with one more byte of data. That's to tell you that I got the 100 bytes of data. Can you send me the other 100 bytes of data? So can you send me the sequence number 200? So 100 bytes of data has been sent. When it leaves the client, it goes to the server, and server is telling that I got 100 bytes of data. So that's why I'm marking it's 101. And can you send the next set of data? So every 100 bytes, it's keep advancing. So for this 200 bytes of data, if you see this, the client acknowledges with ACK number 201. So it means that it got this. So why I am going very slowly with this and why I'm explaining this is the very, very essential fundamentals that we should know to understand all your TCP connection. If you don't understand this, it's very hard. So if you look at this, so it keeps advancing. So it acknowledges 201. So coming to the fifth packet, coming to the sixth packet, client sends more data starting at sequence number 201 and it acknowledges 301. So totally how much data has been sent, has been exchanged? Totally 300 bytes of data. And it got the 300 bytes of data and the server acknowledges with 301. See, the server acknowledges this recipient with acknowledgement number 301. So 300 bytes of data has been sent and the server acknowledged. Okay, so coming back to this, why are we discussing more about this? So the TCP keeps tracks of the sequence number and acknowledgement number. What if some packet is missing? How do we know this? Yeah, let's do a capture now. Let's take this capture and let's see any kind of fragment that was not failed to decrypt data, window size. I think I got some good capture for you to show you the. Yeah, I'll take that capture for you to see this two packets. To G. One second, it's loading. I'll show you that. Okay. So this is the client, right? 192.168.0.135, and this is a server. So we're trying to connect the Microsoft, and the port 443 is used. And let me go to this particular reset package here. Right click, conversation filter, TCP. Okay. As I said, if you look at this, I can see this three-way handshake right over here, right? Since an act back, so I marked with green filter. So I gave the coloring rules. I've given a green color for it. So I see sin, synac, act. And if you look at the sequence number and acknowledgement number, it starts with 0 all the way down is 19,958 bytes of data, 19 MB bytes of data. And if you look at this, this is from client 192.168.0.135 and the destination is 122.24. I'm just looking at this conversation right over here. I see three-way handshake and I see the application traffic. It keeps going, but finally it does a reset. And if you look at this, as I said, if you look at this flags here, it sends the packet with push flag. You open the flags, you can see this push flag. What is it? The wrong packet. Yeah, this is the packet. Yeah, you can see this highlighted with the blue color. That's your push packet. So because of this push packet, see, after this push packet, you see the fin packet and you can see the reset. Again, I'm telling this where you should not confuse with that. We will do the scenario for the reset, the actual reset. So this reset is something I see the successful connection. I see the sequence number and acknowledgement numbers back and it is advancing. I see this is a clean conversation, TCP conversation. I see that, but I have seen a lot of push packets. It's telling that you give your priority to me, push your packets. And because of that, I see this reset. So this reset is not about terminating the connection or refusing the connection. This is about I am done with my conversation. We can gracefully tear down the connection. This is a reset because we have done with the connection. We have exchanged all the data that is intended. That's the whole point of this reset. So coming back to that, so what are the other key parameters you should focus on?